Perfect. As Brian already mentioned, I'm a Menalo technical specialist for security compliance. Microsoft, I work primarily in Canada or in the central region, as we call it, in Ontario, helping many of our customers with their cybersecurity journey. And today's session, I wanted to talk about how we do security at Microsoft, how we've modernized our SOC, a little bit of our journey and what we see in the industry today, and how we kind of leverage the cloud, I guess, for that MLAI, analytics, all that good stuff. We'll talk about some of the buzzwords, and we'll hopefully demystify some of the buzzwords as well. So basically, so where we are today when it comes to cyber and what we're hearing for a lot of our customers is that their tools are not keeping pace. The technology is now a business that everybody's in. The challenge that many of our customers are having, I think, is that the paradigm's shifting fairly rapidly, and cloud adoption just in general has been very, very difficult for many of our enterprise customers. Many of our customers are they're in this hybrid scenario, I would call it, where they have many on-prem resources, a lot of infrastructure, a lot of data centers that they've built up, and they're trying to scale out to the cloud. And that's the same issues that they're having in the security space as well. When we talk about cloud first security, so if you have a platform like Azure or AWS or GCP, and you have workloads that are running there that are native to those cloud platforms, it makes a lot of sense to secure those. But a lot of our customers have data, identities, endpoints, and infrastructure that are on-prem. And so living in this hybrid scenario is very, very difficult. And then one of the big things that we call out on Microsoft all the time, and it's true for a lot of our customers, and it's true for Microsoft internally, we have a very, very difficult time filling this professional security gap. It is very, very, I think the last statistic that I read internally is that they were able to fill roughly 60% of all open roles within Microsoft that have to deal with cyber, only because we just can't find enough people to fill those roles. So it's still a very, very good space to get into. When we talk about how the cybersecurity landscape looks, it is just a visualization in terms of vulnerabilities over time, but we've noticed that, and this is actually from the NIST.gov website, but we've actually noticed that the vulnerabilities have actually increased over the last 3 years. And this is something we've noticed, especially with the advent of COVID. Not only have vulnerabilities actually increased in the last, I would actually say 3 months, the amount of cyber attacks that we've seen at Microsoft, especially in our customer ecosystem, has more than doubled in the last 3 months. So, and I suspect that this will continue with the advent of COVID, with a lot of our customers being forced to work remote. It's changed that paradigm a lot, and it changed it in a number of ways. But I would argue, like last year, we heard very, very little about zero trust. This year, everybody wants to talk about zero trust. Within Microsoft, there's probably 3 topics du jour that have been on fire lately. That's Teams, obviously, because everybody has to do audio video. And in this case, we're using WebEx. I love WebEx as well, so just a call out for WebEx. We get a lot of our customers in that security and compliance space that are looking because they want to extend their on-prem resources out to the cloud. And then we get a lot of people that talk about the zero trust paradigm only because their workers are forced to work remote. And at Microsoft, it's no different. I would say the large majority, roughly high 90%, are all remote working from home. In this case, attack services are very, very cheap. So what we're focusing on here on Microsoft is we don't focus on the 0 days, although the 0 days obviously primarily are solved by just currency alone. We focus on just general hygiene at Microsoft. We focus on passwordless and MFA, and we focus on DDoS protection for our critical services. Only because we see the attack services are cheap. Very recently, I would say, especially in the Canadian ecosystem, we've seen, and I have the privilege sometimes to work with our response team, which is kind of great and gives me a lot of insights into post-breach scenarios for our customers. But we've seen the advent or a rise in cryptoware, believe it or not, in the last 3 months. Cryptoware is, and again, it's a very cheap actually service to leverage. We've seen the rise of Emotet with TrickBot and Ryuk very recently for some of our customers, and it's that was Emotet was something that was prevalent maybe in 2017, and all of a sudden it's made an appearance again, and that's mainly because on the dark web, some of these tools are very very easy to purchase, and sometimes our customers don't do very well on the currency side. Common attacks against the cloud scenario. So this is all kind of root causes misconfiguration, but this is what we see within cloud resources specifically. So we see weak passwords. Weak passwords and password-based attacks are still something we see very, very high. I mean, the vector of attack on Microsoft that we see internally within Microsoft and for our customers tends to still be mail. It's going to be phishing and all sorts of, whale phishing, spear phishing, all sorts of phishing attacks. But specifically, we see weak passwords as being definitely a vulnerability for a lot of our customers. I would say the last response that I actually assisted on for one of our customers, they in a total of, I want to say 2,000 accounts were compromised, and they were actually compromised from weak passwords and lack of MFA. Top hacking actions, right, and breaches. These are just kind of, again, the use of stolen creds. These creds can be bought online. C2, so backdoor or C2 basically, or control, exploit vulnerabilities, and brute force. So this is kind of just what we're seeing across the ecosystem when it comes within Microsoft and our customers. And at the end of the day, complexity is really, really the enemy of security. And this is something we've been trying to solve for with the cloud, and something we've been trying to solve for with on-prem resources as well. Many of our customers, including where we came through from Microsoft, is they're living in a world where there's many disparate technologies, many point solutions that they're just trying to integrate together, and it becomes a challenge. Not so much, pre-breach. When pre-breach is we're living in a world where we're combating the attack, or the tool sets are effective. We're not worried so much about what if scenarios. Post-breach, on the other hand, the ability to recover from a breach scenario is very, very difficult for many of our customers. So much so that, and again, just a little bit of storytelling for one of our customers located in the West that was actually recently compromised. It took a total of 3 weeks to actually come back from the breach. So, they were hit with cryptoware retail stores. There was an outage for a period of, I would say, a total of a week. But in terms of the detection, the response, and the recovery portion took a total of 3 weeks. And that's mainly because, they're coming from an ecosystem of having separate technologies that aren't unified, right? We aggregate everything to a SIM. We try our best to cross-correlate those signals, and we try our best to create our own orchestration. But the challenge really is that these entities, these alerts, these signals tend to be different across the ecosystem, right? And then SOC teams try to do their best, and what happens in a post-breach scenario is they tend to get overwhelmed. So we're finding customers moving from suite solutions, for point solutions into suite solutions. That makes a lot of sense, logically speaking. And even with the cloud, cloud is just a vague term, but there's 2 points for the cloud. We can actually leverage cloud to actually send signals to and aggregate, or we actually have our own services in cloud that generate their own signals, and then we use those. But the massive data that we want to send as much data as possible to the cloud. It makes a lot of sense for a lot of our customers to leverage the power of Azure, the power of AWS, the power of GCP, to aggregate those signals through some type of log collector and do some log analytics against those. Just build this out very, very quickly. And again, we can't stop all attacks, and that's something that we at Microsoft fundamentally believe in. It's not all about post-breach. It's not about preventative measures, especially in a world of remote workers today. And really the cost, and we're noticing this from our customers as well, and and our customers are telling us that they're trying to collapse the stack as much as possible to remove that complexity, because with that complexity, there is a lot of cost associated. And then what we're trying to this last point, I guess, and this last point really does point to the power of the cloud, is the idea or the concept that we try to leverage the cloud for as much automation as possible. Now, a lot of people think like, ML is going to solve all the world's problems, including your security issues. It's not. We're not there yet. But what we can do is we can offload a lot of the processing, a lot of the signal noise, a lot of the incident and alert correlation. We can offload that to the power of the cloud. This is a little bit of insights into how Microsoft protects Microsoft. Um, so how we protect both our corporate and on-prem infrastructure and our cloud infrastructure. So we're big into obviously hardening, whitelisting, auto patching, things that are done on the kind of the physical side, the OS side. Currency is our number one thing internally. And then when it comes to cloud, we're big into secure DevOps. We create a lot of our run books. We do a lot of event correlation. We try to remove the noise, and we'll talk about that a little bit in a few more slides. But we try to remove as much noise for our security analysts as possible. We do continuous scanning. We do penetration testing on a yearly basis, usually on a bi-yearly basis or more often. We actually leverage other third-party resources as well to come in and do some penetration testing on our behalf. And that goes against cloud resources and on-prem resources as well, only because we want to use the power of the cloud to attack the cloud as well, because that's what a lot of our adversaries are doing at this time. And this is actually Microsoft's internal approach from our SOC. So we actually use the power of ML and AI and some behavioral analytics on the user space for our accounts and our identities to really enforce that 90% true positive on some of the alert feeds that we get. Because we get billions and billions of signals, it's actually trillions of signals a day. It's very difficult to separate the noise from true positives. So we actually use, and I'll talk about that hopefully in a few slides as well, but we use a lot of our ML not to solve all our issues, but actually for the tier 1, tier 2 of our SOC to actually remove a lot of the signal noise for them. So they actually get only rich, in-depth signals that they can use. And the only way we can do that is leveraging some of our technologies in terms of log analytics and Sentinel. You'll hear on the Microsoft side, obviously we're a Microsoft focused shop, but it's no different if we're leveraging it as a signal from AWS or GCP as well. This is the trillions of signals we've like to talk about. This is obviously in relation to what we call the intelligent security graph at Microsoft. The intelligent security graph is basically it's a mesh network across the entire stack. So when we talk about the stack, like we're very much in the mail space and the data scanning space. We have endpoint detection and response. We have identity and UEBA products. We have CASB solutions or cloud access security brokers for data exfiltration and cloud application access. And then we actually have Azure Security Center and Sentinel as well, which are cloud-powered products to help secure Azure. But across all these services, Exchange Online, SharePoint Online, we collect trillions and trillions of signals, and we use a lot of those signals in terms of our security to provide some depth and to provide a lot of good analytics across the ecosystem. So when we talk about machine learning specifically and how it helps us, it actually helps us scale out human expertise. So we actually have tier 1 SOC analysts and tier 2 SOC analysts that actually use a lot of the actual signals and alerts and incidents that are coming out of ML. So usually what we do is we collect the sensor, right? And it could be, imagine a scenario where we collect, and it doesn't have to be a Microsoft signal. Like obviously within Microsoft itself, we were running on our endpoints, we're running Defender ATP, and those signals are being sent directly to Azure and they're being processed there. But imagine a scenario where we're running, I don't know, Cisco on our firewall or Broadcom or Symantec for DLP. We want to aggregate and collect some of those signals as well. But what our ML actually does for us is that it helps aggregate and correlate those events. And it helps us actually rationalize some of those events as well. Because what we want to do We want to normalize as much data as possible. And data normalization is all about taking an event, and it could be something as easy as, hey, we have an IP and we have associated username and a couple of more fields, but we need to normalize that data before we can actually use that data. And that's really what machine learning does. So machine learning could obviously work on that actual data set, and then it sends the data set through basically a decisions tree or decision graph where our ML actually looks at whether or not we believe this to be malicious. And for an identity, it could be based on behavioral analytics. And hey, has Ivan logged into this cloud resource at this time before? Or on an endpoint, it could be, hey, is this portable executable? Is this malicious, based on live detonating the executable and figuring out whether that portable executable actually has malicious code or malicious intent inside. One of the things that machine learning also brings, though, is it can amplify human bias, and this is obviously with because we do have a Microsoft data scientists in the back, and there's usually a lot of our customers have data scientists too, in terms of because they collect a large amount of data, and they the people that write these reports, that write the queries, that sift through the data, these tend to be the data analysts, and we're no different. But what it can do is that the data analysts actually supply some of their own human intelligence. And what happens is that ML can actually amplify that. So when it comes to actual malicious data feed, for instance, and we ML comes up with a score and says, hey, this is 70% malicious in terms of reportable executable. What happens is a data scientist could look at some of the data, help corroborate that data, and say, yes, I believe this to be malicious, and they pass this forward. Now that same logic will be applied to a greater data set. But there's actually a chance of false positives occurred, but we've applied to the greater data set that false positive. So that's where we can actually amplify that human bias across the actual data set and across the ecosystem for a lot of our customers. What we use machine learning for specifically on Microsoft is to reduce the manual effort, as I mentioned, reduce the wasted effort on false positives and speed up the detection. It's obviously removing the noise. And a quick one on there is the Defender ATP. I'll talk about that specifically. That's Defender Advanced Threat Protection. That's a cloud service that we can send executables in real time and actually detonate within a virtual machine and send back results within seconds, if not minutes. And we actually do a lot of that to reduce the effort and speed up the detection on the end user side, because we're at the end of the day, we're just having a user that's actually downloaded something or clicked on something that's malicious through an email, and we're actually leveraging the power of the cloud in real time to actually evaluate that result. This is actually based on our former rule-based scoring. So 28% at one point in time of our malicious logins were actually rendered as suspicious, right? And there's a variety of reasons. So we said, hey, company added proxies, cell phone networks in use, vacation and travel. So for instance, I went to Croatia about 2 years ago, and right away, something like identity protection would pick up, hey, you're going to a location that you don't normally log into. But there was actually nothing malicious about that sign in. So after we applied a lot of our machine learning models, that percentage went from 28% to 0.001%. And actually, we've applied a lot of these models in the last 2 or 3 years, and we're seeing the detection rates get a lot better and better. When we talk about machine learning specifically, and again, this is to defend our AV, and this is actually just going to give you a quick example. This is Dofoil. This actually happened a couple of years ago, but that being said, it was caught within roughly I would say within minutes, I believe it's 8 minutes within our power of our cloud. What happened is there's obviously a patient zero. This is a 0 day. This is a post-breach scenario. The protection within milliseconds came in from our client ML that detected something malicious, but it needed the power of Azure to actually collect metadata and sample analysis for some of our ML models. So we've actually sent some of those samples to the cloud. The cloud reasons upon that. Actually, within minutes, we detonate that within Azure, and then we actually send results back in real time to those endpoints. So believe it or not, 400,000 instances of this Trojan were actually caught, and this is within the same day. So again, there's always going to be a patient zero. Always, we assume breach, but with the power of ML, we can come back to a good known state and we can recover fairly quickly. I will say, in terms of things that we've seen with other vendors, especially without leveraging the power of the cloud, and especially when we're definition based or we're looking at things that's not behavioral or we're not leveraging some of the compute power that we have, we've seen that recovery time take weeks and months, and we've even seen the actual mitigation on our customers' environments be days, which is just a little bit crazy when you think about it, because when you take days to actually mitigate that attack from happening as well, sometimes the only thing our customers can do is just turn off the lights. Um, Basically, we've seen here, it's just saying we've seen malwareless attacks, fileless attacks, tailored target attacks over time. So a couple of years ago, fileless was very big, PowerShell, any kind of scripting language in memory attacks. And then obviously malwareless attacks is kind of like social engineering. We've seen the rise in that event of that. And so how do we combat some of these attacks? And so most corporate IT, they just do this classic model of SIM, aggregating all these types of attacks to SIM, and SIM has classically been on-prem, but a lot of people are scaling out to the cloud, which is very smart and responsible. But the challenge there is, unless we're doing something that with that data, we're still going to have the same issue that we're having with on-prem. We can scale out the data collection piece, but really what we're trying to scale out is the processing power against that data. So, and a lot of our customers are run into the storage volume costs, false positives, and poor investigation workflow. So a lot of our customers build out, using Demisto Threat Connect, any other sort or orchestration tool, they built out, automation on top of their SIM. But the challenge really is they're not leveraging anything natively. They're just trying to do as much event correlation as possible, and that's where we're seeing a lot of our customers struggle, because they're collecting millions, if not billions, of events, and having those events correlated to be easily readable by a tier 1, tier 2 analyst is very, very challenging. This is a little bit of how we do it at Microsoft here. We actually aggregate all events, and our platform obviously is a little bit unique than AWS or GCP, but I mean it is no different when we look at a cloud first model where we aggregate all these events from different areas, and it could be Azure assets, SaaS identity is both our cloud identity and our on-prem identity and our endpoints. And then we do a lot of work with third party, right? And I mentioned data normalization. So we're undertaking a project internally where we're normalizing all our data sets across all third parties. So if it's a firewall, and a firewall throws an event, and that might look unique to that firewall provider, we're actually ingesting that data, we're normalizing the event, and then we're actually we have our own entities basically, and we're cross-correlating against those entities, only to make the tier 1, tier 2 SOC person's life a lot easier. This is how we look at the tiered approach when it comes to Microsoft. This is how our internal Microsoft SOC team kind of operates. So again, we use automation, and we have something called Microsoft Threat Protection. That really is, and I think we'll talk about it a little later on. It really is cross-platform detection and response. Actually, we were going to name Microsoft Threat Protection XDR, but we actually went with the name Microsoft Threat Protection specifically. This is just cross-platform, cross-stack endpoint detection and response capability. So we actually try to take automation, and 90%, and again, our rule set is 90% of true positive alerts, and that's what we try to feed out of our automation. So not only is our automation there to actually get rid of false positives, our automation is really to handle as many alerts as possible before sending that alert to the tier 1. And I'll give you a good example, like a quick example. I actually, believe it or not, within the last month or so, I downloaded some malicious code, perhaps on purpose. I will say it's accidental, but to my actual corporate laptop. Within, I would say, 30 seconds, there was a workflow kicked off where I received an email notice with all the forensic data that they needed to show that I went to a certain site, which happened to be GitHub in this scenario. I downloaded some malicious code. It gave me they sent them, the email was delivered with my Outlook inbox. I had a button that I had to click saying yes or no, was this maliciously done? A text field that I had to actually send why I did this, and I actually submitted it. And then within seconds as well, my manager and his manager were notified, and a workbook was actually picked off. That's basically what we call automation at Microsoft. And that incident went from all the way from being detected to resolved within, I would say, in total of 30 seconds. And that's really, really what we try to aim for at Microsoft. When we talk about tier one alerts for this default top path, those are alerts from our tooling, obviously. There's some user reporting, which actually happens to be roughly 10% on Microsoft. User reporting is when a user believes something to be malicious, they actually report them on their own. And then log events or others is any other third party, basically. And then what really is tier one, tier two. I would say 95% of all alerts are actually managed by tier one, tier two. Tier three only comes in 5%, and they really are just managed hunters. So they do advanced forensics, and they actually are proactive workers where they actually look at all the voluminous data ingested within Sentinel. They do a lot of data analysis against the log analytics workspace, and they come up with a lot of, hey, they're going to be proactive not only in their hunting, but proactive in some of the configuration or setting changes that they recommend to our customers. This is just a very quick technical resource in terms of our security operations. It's a little bit busy, a little bit noisy. It is worth calling out that we do play nicely in the Microsoft ecosystem with third party as well. We're seeing most of our customers, and they're not adopting this type of security operations model, but we're seeing a lot of our customers adopt a type of a hybrid model to this. Some of them call them fusion centers as well. Some of them ingest data and have multiple teams that are security people specifically and non-security people, depending on where they're getting their data sources from. Basically, what a fusion center is that we're trying to get intelligence from areas within our business that are normally not thought of as security. So at Microsoft, our crown jewels are obviously code, code, I would say, obviously, and some of our cloud resources as well. And we have specialists in those areas that actually work with our SOC resources on a day-to-day. I will skip some of these just for the sake of time. I will show what Microsoft Threat Protection is at a high level here. And this is a protection that we offer across the attack kill chain. So basically, what you see here on screen is obviously Office 365 ATP, Microsoft Defender ATP. This is our mail solution. This is our endpoint solution. This is our UEBA for cloud. This is our UEBA for on-prem, and that's our cloud access security broker. And this is actually how we protect across the attack kill chain. And then we aggregate all of these signals. And then we have a unified portal. This is what we call suite solutions, right? So suite solutions are XDR, extended detection and response capabilities, are really suite solutions that play across the ecosystem. And then we actually aggregate all these signals to the cloud, right? And then with the cloud and with the power of Sentinel, which many of our customers may or may not have heard of, that's really the pane of glass that we look at through our SOC team day to day to really actually detect and respond against some of these